Hello.
Hey, what's up, brother? How you doing?
Good. I think we've talked before. I think I was on your show, so you being on mine. But
Oh, okay.
yeah, I remember yesterday you requested that I came across your live earlier, and you looked familiar, so I think I've been on yours.
Oh, okay. Still want to talk or?
Oh yeah, no, it's fine. Your background was like the polar opposite of mine. I think. I promised I didn't steal mine from yours.
That's okay. I've been doing this for a little bit over a year now, so
Yeah, yeah. So you believe the flood literally happened, right?
yeah, absolutely.
And then you believe that like evolution,
Yeah,
macro
evolution is.
evolution. Yeah.
Yeah, I believe in micro.
Okay. Okay. I don't know what you want to talk about. Like, you can talk about radiometric dating, maybe.
I mean, I'm not a big fan on the age of the universe or the Earth because I don't. My honest answer is I don't know. So I would prefer to do. I mean, I can talk about radiometric dating, but I know you did that yesterday too. But more, my thing is more evolution and the flood. But we'll talk about whatever you want to talk about, brother.
Yeah, I think the reason I would be interested in radiometric dating is, if you make a distinction between micro and macro. Let me put you up here at the same size as me. Then,
I would.
for me, it would relate. Saying
Sure.
microevolution over a long period of time would be macro, but
Well, I see evidence for microevolution. That's testable and observable. I just don't see any evidence for macroevolution.
do you think if there was there is microevolution? So, do you think if given enough time that microevolution would have produced the same effects as macroevolution?
That's the theory. So if macroevolution was true, I would understand that microevolution would have to be the mechanism. The problem is I just don't see any evidence for macro, so I can't make that leap. I can say that micro is true because I have evidence for it. And if macro was true, then I believe the mechanism would be micro.
Okay, yeah. So I think we agree then. Because in my head, if we put it in terms of numbers, let's say there's a 0.001% chance change. Excuse me, not chance. 0.001% change between an organism and its offspring. Given 13 billion years, that accumulation would add up pretty quickly over generations to the point where the end result would be very distinguishable from the beginning.
So why is it in 80,000 generations in our lifetime, or within our generations, excuse me, we went from an ape-type ancestor to a human-type ancestor, but in the same amount of generational count in bacteria, we don't see that information gain. In fact, we see degradation. So why is it long ago and far away all this information gain happened, but when we test and observe it today, it's degraded information?
Probably because the selection pressures would be different. The things that cause the organisms to evolve would be different.
So what's different about it? I mean, is the Earth changed or just
No,
long
not the
ago and
Earth,
far
but
away?
I would imagine that bacteria, the environment that bacteria are evolving in, doesn't have the same kind of pressure to change in the same sense as that humans evolved in. It's not change or like with bacteria. You said we can observe thousands of generations of bacteria pretty quickly because they repopulate so fast, right? And so there's not as much of a I guess I keep using the word pressure, but there's not as much of a pressure for an individual to vary very much from its ancestor, right? With humans and apes and larger mammals, there would be.
So is there anywhere on the planet today that evolution is happening? Or is the selection pressure just stopped?
I don't think it stopped. I think you would know my answer to that, right? Yeah, I would say that evolution is still happening.
All right, so it is happening, just not for bacteria.
No, it's still happening for bacteria too. But
So then why is it long ago and far away within 80,000 generations we see evidently macroevolution happened, but we just can't see it today? I literally thought, maybe I misheard you. I thought your answer for that was because the selection pressure has changed for bacteria. But then you said it is still happening, so I'm a little confused. Why is it long ago and far away, within 80,000 generations, we saw this huge evolutionary change in humans, but when we do it with bacteria, we don't see that?
Well, I think I just explained that though with the selection. Maybe I didn't explain it well enough, but the pressures are different. The environmental pressures are different. So this is how I see it. The environmental pressures are different enough for humans to encourage a more rapid evolutionary change. We have longer generation, longer lifespans, fewer offspring. Those are all things that would suggest that evolution would have to change faster from generation to generation, rather than if I made 3,000 copies of myself in 30 minutes, then there's no need to change that much. And indeed, the pressures wouldn't exert any
Okay, so the selection pressures
any
is
change on
so
it.
so I accurately got you then. So it's not for the selection pressure is not big enough for bacteria to evolve as much as we would expect, but it still is for humans. So the way around that I would say is for evidence of macroevolution, I would need to see genetic information gain. Genetic because you got to be able to pass it on to your children, information as far as new structures, new function, new code, new DNA, and it'd have to be gained from something that wasn't there. So do you have any example of genetic information gained that's testable and observable that's not inferred?
Yes.
Like what we got?
Would you like? We can talk about the like the development of lactose, like the ability. I think it was E. coli to develop the ability to digest lactose in an oxygenated environment.
It was citrate, but yeah, I know what you're talking about.
You're right. You're right. I think there's a lactose one as well. I have my computer here.
Well, they eat lactose in oxygenated environments, and then it started to digest citrate in an oxygenated environment.
Yeah, you're right. I confused the two. Yeah, citrate, and then EBG lactose.
Let me grab my phone charger real quick. So, are you aware that the bacteria already had the ability to digest citrate?
They couldn't digest it for food though.
Yeah, they could. They just couldn't do it in the presence of oxygen. But they already had the ability to digest citrate, right?
Okay.
Yeah, so that's not evolution. They just doing what they already have the ability to do would not be new information. That's literally existing information, right?
Well, they didn't have the ability to digest citrate in the presence of oxygen, right?
Right. So they had a duplication event that got stuck under a promoter gene. So, but again, that's not new information. It already had the ability to digest citrate, so it didn't evolve this grant. It could already eat into food sources. So basically, what happens is it has transfer
not in
proteins.
the presence of oxygen, right?
That's true. Yeah, not in the presence of oxygen, but it's also the way we word it. Like I can say that I'm immune to handcuffs if I lose my arms. Right. By the way that I phrase it, it makes it sound like I've had this gain of information by stating that I'm immune to handcuffs by losing my arms, but actually I've lost information. So what happens is the transfer proteins that allows in glucose, the transfer proteins change shape in the presence of oxygen or unoxygen. So when there's no oxygen present, the transfer protein changes and allows in citrate. And then when the oxygen is present, the transfer protein allows in glucose. So when there's oxygen present, it eats glucose. And then when there's no oxygen present, it eats citrate. And we can literally see that these things are devolving. They're losing their flagellum. And they still have the ability to digest glucose, but at a degraded rate compared to their ancestors. So it is true that they started eating citrate in an oxygenated environment, but they did not do this through this information gain. They already had the ability
not
to do it ahead
information
of time.
gain, but function gain, maybe. Would you say it's a gain of function?
Yeah, by the way that we're phrasing it, would be a gain of function, but it's not through information gain, which would not be evolution. That's my point. Doing something it already had the ability to do is not evolving.
I'm trying to understand your standards. Like if you had a strand of DNA, let's just use normal alphabetic letters for example, like ABC. If the strand of DNA said ABC, and then it was duplicated by mutation in the next generation, and so it said ABC, ABC, would you consider that new information?
No, it's existing information. Right.
Okay.
So that's why I defined it to begin with. And so genetic information gain, genetic because it's got to be passed on to your children. It wouldn't matter if you had this great evolutionary mutation if you couldn't pass it on, right? So genetic information gain, genetic because you got to be able to pass it on to your children. New information as far as new structures, new function, new code, new DNA, and it'd have to be gained from something that wasn't there before. And you and I would agree that if you went from a single, or at least you'd have to, I don't want to put words in your mouth, but if you went from a single-celled organism to a fully functional human, the genetic information gained literally happened quadrillions of times. I just need an example of it that's testable and observable and not inferred. And Linsky's bacteria that started, they're degrading, they're losing information. And them learning to eat citrate when they already had the ability and framework to eat citrate is not evolution. It could already do that.
Yeah, that's why I was curious on your opinion of if a piece of DNA is copied, you would not call that information gain. What if it was copied and then mutated afterwards? So instead of it being ABC, ABC, it said ABC, ABD. Would you consider that new information?
Well, I'd have to see it in if it expressed in new function or new structures in the way that I defined it, because I believe in mutations and I believe in duplications. And I understand you guys think that's the mechanism, but that's why we have to see it portrayed in these new ways. So
if it
just
provides a
the
new
way
function,
that you
then it's
phrased
new
it,
information?
no. If it provides in the way that I define it, yeah, not just a new function, but because the way that you define it, again, it's the way that I word it.
I'm trying to get to your
I
definition of what information is.
Well, that's what I'm saying.
Right.
If I phrase it that I'm immune to handcuffs by losing my arms, that's clearly not information gain. But the way that I have phrased it, it makes it sound like I have this new information, right? It sounds like I have a gain. I'm now immune to handcuffs, but I've lost my arms. That's not evolution, right?
I understand.
So that's why I phrase it
ABC, like that. ABC, and then the offspring has ABC, ABC. That's not new information to you.
It's existing information.
It's
yeah,
okay.
Well, I believe in copies. I believe in duplications. I believe in micro. That's literally what micro is.
So if the parent has a genome that says ABC and the child says ABD, would you consider that new information?
If D added new functions, new structures, new code, new DNA, absolutely.
It added different DNA. Different DNA? Is that fair?
Well, I mean, it would be DNA, but if it added new structures, new function, new code, which would be DNA,
that's what I'm confused about because like ABC and then copying that, so it's ABC, ABC, that's adding new DNA. And so I'm trying to pinpoint exactly what
that's
you're
duplicating existing information. Like if I grew another arm out of my because sometimes DNA gets messed up, right, and it duplicates, and you can grow additional things that that normally you wouldn't have. So let's imagine that I was born with 3 arms instead of 2. That's not new information. That's literally duplicated information, and usually it's a problem. But it's not new information. The code to write my arm that the DNA possessed was already there, and it doesn't tell you how the code got there. Duplicating information doesn't tell you the origins of the code, and it doesn't write new code. It's literally just duplicating the code.
Okay.
And that's what
I guess
we agree
to disagree there.
Well, I mean, but you got to give me an example of that. You can disagree with it all you want, but show me an example of bacteria eating citrate when it already had the ability to eat citrate is not evolution.
Right, I agree with you. That is not evolution. That's not what we're talking about, though. Like we're talking about in the presence of oxygen. And then it's a different function. So different is not new to you, I think.
Okay, can that get you to macroevolution?
Well, if we don't agree on this, we're not even going to get close to agreeing about macro. But
yeah, but
I don't understand. I don't understand.
You got to show me the origins of these things.
On one hand, you say if it encodes new DNA, then it's new information, and then on the other hand, you say if it encodes new function, then it's new information.
Yeah,
so you can have new DNA without new function, and you can have new function without new DNA. So I don't understand.
Well, I think I've explained it pretty well by stating it's also the way you phrase it, right? Like if I phrase it like it's a gain of function by stating that I'm immune to handcuffs, and I've used that example plenty of times, not to sound disrespectful, I can't make you understand it, but that's why I use that, right? If I lose my arms, I can phrase it in a way that makes it sound like it's this gain. I'm now immune to handcuffs. But that's not information gain. And we can agree to disagree, but bacteria, eating what they already ate to begin with. They already had, let me show you like this right here, right? Let's do the finger test. You got Linsky's bacteria in the wild, outside of his experiment, has a flagellum. They're able to eat in oxygen. They're able to eat in unoxygenated environments. They're able to eat glucose, and they're able to eat citrate. Linsky gets a hold of them. They're losing their flagellum. They're able to eat in oxygenated environments, but at a detriment to glucose, excuse me. They're able to eat in oxygenated environments and unoxygenated environments still, and they eat glucose at a detriment, and now they can eat citrate in both environments. Which one's evolved? Mm-hmm. You got the wilder bacteria that has a flagellum, can eat in two different environments and two food sources. Then you got Linsky's bacteria, losing their flagellum, can still eat in two environments, but has a detriment at one of the food sources now instead of the other one. So it's not evolving, brother. It's a math problem. If it keeps going at the rate that it is now, it's eventually going to go extinct.
Okay. I guess we agree to disagree there.
Okay.
Okay. Another aspect of macroevolution. Let's talk about transitional fossils, maybe.
Okay.
Would transitional fossils, we can define that, would that lower your confidence that creationism is true and raise your confidence that evolution is true?
No, my falsifiable viewpoint would have to be genetic information gain the way that I defined it, because fossils are nothing more. Yeah, the reason
talking with you.
the reason why is because fossils are shapes and assumptions, brother. You literally I could say that fossil is the end of that animal's lineage, and you couldn't prove me wrong. You'd have to prove that fossil had children and had children that lived. And if we're being intellectually honest, literally fossils are nothing more than shapes and assumptions. You see shapes in them, and then you just add your assumptions on them.
Okay, so it's just the genetic piece that would lower your confidence.
I mean, I'm open to any evidence. I'll listen to any evidence. I'm not going to sit there and say automatically without looking at evidence that I'm going to shut it out and not. I'd like to think that I could look at evidence, but fossils, it would be hard because you have to prove that fossil had children and had children that lived. And I'd like to do this little fun thing here. Let me show you why. And don't take this as an insult because it's not to you, period. But let me show you this right here. So this is turn my camera around here. Well, I can't actually. I got to turn this around. So, can you see the spoon on the screen?
No, your background's covering it.
Oh, is it? Okay, let me turn my background off then. If I can, I might not be able to. Let me see if it lets me. No, that didn't work either.
I turned your camera off. I think if you go to the little wand and then hit effects,
yeah, there it is. Let's see if it lets me do it now. Okay. All right. How about now? Can you see the spoon?
Mm-hmm.
All right. So I was in my yard the other day, and I dug a hole in the ground, and I went through many of the different layers in my yard, saw the stratification. At the bottom layer, I found this spoon. And I thought, well, that's just a spoon. Who cares, right? But then in the layer above that, I found this spork. And as you can see, this is clearly the same kind, right? They have the same anatomical structures, but you start to see these grooves coming into the spork here. But then I thought, well, that's just two fossils. That doesn't make anything. So I went to the next layer, and I found this salad fork. Now you can clearly see that they're the same animal down here at the bottom, but the top, it's starting to get skinnier on the sides, and the grooves are going down a lot farther. So clearly this is a transitional fossil between the spoon and the spork. And just to add insult to injury, at the very top layer, I found the fork. So now we have this extra structure here. Clearly they're all the same type of animal. And these are transitional fossils between the spoon and the fork. Now, that's a silly little thing I like to do to show people, but that is literally what the fossil record does. You see these shapes, then you literally just add your assumptions to those shapes because they look alike. And we clearly know that the spoon did not evolve from the fork or vice versa, but that's literally what the fossil record is. It is placing the shapes and assumptions on the fossils.
Do you think a fossil is older if it's below in a stratigraphic layer below another fossil?
No, because then you got a problem with polystrate fossils and dinosaur soft tissue and DNA.
Okay. When sediment's being deposited, which does the top of the sediment deposit, is that the younger rock or is it the older rock?
Well, it depends on how you define it. Yeah, it would be the bottom would be laid down first, so it would be older. But when we say older, what do we mean? I believe it's within a year. All of these layers in the geologic column are within a year of each other.
Absolute dating aside, relatively, it would be older than the ones on top. You think?
Yeah, within a year. So if this one was laid down on day 1, this one right here was laid down on day 365, then yes, this one is a year older than that one.
Okay, so then we agree on that point then. Like the laws of stenography, like how everything's layered. Like if A is down here, B's here, and C's here, C has to be younger than A, and B has to be in between the two.
Yeah, but
Yeah.
I just want to make sure that we're clear. When I say younger, I don't think of geological time frames as in millions of years. I think this was Noah's flood, right?
I'm just talking about relative. Okay.
Right.
So if you find a fossil that's below a different fossil A is below fossil B, would you say that fossil A is older than fossil B?
I wouldn't say older. I think they all lived at the same time. I'd say that it got laid down first, but that doesn't make the fossil itself older. It just means.
But how could the rocks be older, but the fossil not?
Well, it would still be the same. It would still be the same time, but these are not organisms, right? So these you start the age the moment they get laid down, right? A fossil you wouldn't do that, right? Because a fossil lived. So you could have, let's say, a baby deer and a mother deer get separated from each other. And the mother deer floated because she was a lot larger, whatever. She had more gases in her system, so she floated during the flood. So the baby is actually buried at a lower strata than the mother, right? But it's still roughly within the same time.
But it was buried first.
Right. So
like it was buried first before the mother.
Right.
But it doesn't make the baby older.
But it didn't make the baby older, right?
Yeah. Okay. Okay. Just interesting. I'm just thinking about it. I might ask something like, no, never mind. I don't want to ask that. But if you have any questions for me, let me know.
It's your show, man. I usually control my live, but this is your playground.
I don't care. I really don't care.
All right. Well, what do you think about the soft tissue and DNA fragments found in dinosaurs? I would imagine you believe they're millions of years old.
Right.
So how do you contend with the soft tissue and DNA fragments?
I'd be happy to grant it, actually, and say perhaps they're young. I think the larger issue would be that we don't see that in an overwhelming majority of dinosaur fossils. I think that would present a harder problem.
Well, they're actually stating now that the soft tissue is actually relatively common. DNA is very new. That's a very new thing, and I'm only aware of one paper that has that. DNA is new, but the soft tissue is actually commonplace now. They've been finding this for over 20 years. I'm not saying
so. Like if I find a dinosaur, well, shoot. Hey, I've got a piece of an ammonite right here. I've got my ammonite. I've got a larger one in my living room. It's like a full one. This is just a piece of one. I found this a couple miles from where I live. But like, would you say like this would have DNA in it?
I don't know if that. I have no idea. I don't know if that has DNA in it or not.
Well, it's a living animal. It was living.
Well, at one point it did.
This
I don't
is
know
like
if the fossil has any DNA in it or not. I would have to see the paper on it.
Okay. Like this was a living organism, and if it was buried 4,000 years ago, like we would be able to find DNA in its fossil, right?
Now the half-life is 527 years, so I would expect that we could make some predictions that you should be able to find some DNA in some animals, but it's 527 years for a half-life. Even 4,500 years, you really shouldn't hardly find any DNA. You can find probably fragments, which is what they're finding, but 65 million years is just impossible.
Okay. Yeah, I think the reverse case is probably stronger for me. That like if there is DNA in these fossils, and if there is DNA in these fossils, then we would expect to find that with literally everything that's buried.
Well,
because if it
that's
was all buried 4,000 years ago.
well, I can make some predictions. I can predict that once the mechanism is figured out, which, funny enough, Mary Schweitzer done this too. She's also the scientist that found the soft tissue, and just like the soft tissue, they come out and they didn't like it at first, but now this is commonplace. So I would imagine within the next 10 years, it will become commonplace. That's my prediction because that's exactly what we saw with the soft tissue, and the soft tissue is collagen, and it has a half life of about, I think, 100,000 years, if I'm not mistaken, in the best ideal conditions. So it can't go out to 65 million years, the collagen. So you got a problem with soft tissue and DNA. It's different. So
Isn't that predictions aside? Isn't that a circular argument though? Because you would be assuming that what the scientists say about the decay of collagen is true, or are you like internally critiquing my worldview? Does that make
no,
sense?
yeah, but I go with like testable and observable science. I have a
'Cause
problem with the
I,
inference that people make, but not the testable and observable science.
I think it's because I don't think scientists would say collagen lasts 100,000 years. I think it would be longer. I think it would be millions, hundreds of millions of years, right?
Well, we can go to the
To be
papers
consistent.
of the half life of collagen, and in the most ideal conditions, which would be, if I'm not mistaken, like frozen permafrost. If I'm not mistaken, it gets you have a half life of about 100,000 years. That's in the best conditions. So I was actually giving you the best case scenario because most of these the collagen that's found in the dinosaurs are not found in the best conditions. Clearly, they're not in permafrost. All right, so the ones that they're finding is in the Morrison and Hills Creek Formation. So clearly, that's not in permafrost. So I was just helping you out as far as the biggest numbers that you could possibly use to help you out in your position. It still can't go out to 65 million. That's my point.
Okay. Um, if DNA has I don't even know if half life's the appropriate term, but if DNA decays,
Well, it is. I can
we
show you the
wouldn't.
papers. It's literally called Half Life. I can give you the paper
Okay,
of DNA
that's
Half
fine. I
Life.
believe you. Yeah, I don't mind. Um, like if the rate at which DNA decays is accurate, then like you said, we shouldn't find anything with DNA in the rocks. And to me, that supports like an evolutionary worldview. What am I missing?
Well, because so your DNA half life, it goes from a half, then it goes to a quarter, then it goes to an eighth, then it goes to a 16th and a 32nd, a 64th, and so
Mhm.
forth and so on. And technically, it never ever goes to zero, but it goes to a point to where you can't measure it.
Right.
So if I'm not mistaken, the calculations off the top of my head without looking at the papers is about 6 million years, I think, for collagen or DNA. So if you could find just small amounts of fragments, that would support the 4,500 year view, right? But not the 65 million view. That's my point. I can make predictions based off of my worldview that if DNA is going to be found, clearly it's going to be fragmented and be a very small amount. And that's exactly what we're finding because it's 4,500 years ago. That's well within the degradation models. It's not for the 65. That's why I'm saying it fits my model, not yours.
Yeah, I think, but I'm being pretty charitable here because I understand your perspective. I used to be in your shoes, I guess. So I'm more charitable than some atheists would probably grant me. Um, what am I trying to say? The outliers for my data are not as big of an issue as the outliers for your data, and that's why I would say
But
that
like,
my view is more reasonable.
okay, fair enough. But like what? So
Yeah.
far, we haven't brought any information gain, and
Yeah, right.
this
So
model
like
doesn't help. So
that's why I was curious what would change your mind or lower your confidence on anything. And if we can't agree on the information, like what exactly information is, then obviously we're not going to get anywhere. But this is TikTok; it's for entertainment. So um, I wanted to ask about like other human species and human evolution. Thoughts on that?
it depends on on the one. I know VOR talked to you yesterday. He's a lot more educated in this than I am because usually I just
Mhm.
don't do the fossil stuff because again, you have to prove that it had children and had children that existed. So uh, I would say some of them like Neanderthal. I think Neanderthal was probably just a human. I mean, they had musical instruments. They buried their dead. So they're anatomically
Mhm.
just like us, with the exception of trait isolation, which is no different than what we see in tribes that get isolated today. So,
Okay. Thoughts on fossils that share ape characteristics or other ape characteristics and human characteristics,
yeah,
like a
common designer.
divergent toe bone with an
Yeah,
upright pelvis or something.
yeah, common designer. That was my whole presentation on this fork and the spoon, taking things that look alike, and just because they have similarities, then implying that we came from them just literally based off the shapes and assumptions is inference, right? That's all inference.
Yeah, I mean, I would agree with you if that was true. Um, I obviously don't believe that is true. That it's only based off of shape and assumptions.
Well, do you got some
Because then
evidence outside of shapes and assumptions in the
we
fossil record?
then we talk about radiometric dating, right? But I don't
I
know if
mean,
we
we
want to go there
can,
or not.
yeah. Oh, yeah, we can, but I mean, it's still
Okay.
shapes and assumptions was what you're assuming on these things. But radiometric
I don't
dating
deny
was,
that fossils. I don't deny that fossils require interpretation. Like that would be dumb to deny. That's why there's so much dispute within the paleoanthropology community of like how to classify certain fossils.
yeah.
But I do think it's too far to say that it's only based off of shapes and assumptions.
Well, then give me something that's not shapes and assumptions.
Okay, so let's talk about radiometric dating.
Okay.
Do you believe radiometric dating is reliable?
No. I can give you
Okay,
examples
can
where
you
it's
tell me
not.
why?
Yeah, because the three fundamental flaws that you have in radiometric dating: one, you have to assume the parent material, daughter material. Number two, you have to assume the decay rate remains constant. And then number three, you have to assume that it's in a closed system. The only one that I'll
Okay.
grant is the middle one, but I would like to notate it's a nuclear force. The decay rate is constant, but we've only observed it for 100 years. Anything past radio 14 goes into the billions of years. So you want to extrapolate because we've been observing it remain constant for 100 years, that therefore we can extrapolate that it remains constant over a billion years. I think that that is a ridiculous extrapolation. And the amount of assumptions
Okay.
that goes into it is how you get your ages.
Okay. So you said you'd be willing to grant that the half-life decay has been constant.
Yeah, that's a nuclear force. So that's the one. And because we have tested and observed it remaining constant, I'll grant that one.
Okay. Closed system. I don't know. I don't know where to push on that. You say that we assume that it's a closed system
If
with
radiometric
radiometric decay.
material, yeah, if radiometric material can leach in and out of a system, then clearly you couldn't use it for dating. And a lot of scientists pick and choose with this. If
Do
the
you
date fits them, then they just say that it works. If they say that it doesn't fit them, then they claim leaching. I can show you dinosaur bones, right? I'll give you two mechanisms: the soft tissue and the DNA fragments, but they're also finding carbon 14 in dinosaur bones. Carbon 14 has a half life of 5,000. It can't go past 50,000. So now you got another problem with radiometric dating because you got carbon 14 in dinosaur bones. So mainstream scientists will
do
now
you
just
think
claim that that's leaching. Groundwater brings in radiometric material.
do you think radiometric dating can be specifically like the radiometric dating of zircon crystals can be influenced by seeping of radiometric material in and out of the zircon crystals?
Oh, absolutely.
Okay,
Yeah,
and
when
why do
we
you
say
believe that?
things like because it's been tested and proved, all you got if you got phosphorus, I think it is, which is the 11th most abundant element on the planet. If phosphorus is around, it actually carries lead into the zircon. You can see that in lab grown zircons. I'll give you the papers if you'd like. They have like 0.000.1 lead leaching, meaning that the natural zircon crystal resists lead and has uranium, so it should be good for dating. Only problem is if I believe it's phosphorus off the top of my head, if that element is around, it brings lead into the material to like 1,500 parts per million. So it goes from zero to basically like 1,500. So it
Okay.
jumps dramatically if this one element is present. Now
Do
zircon
you
can
think there's
actually
any?
move it in and out of systems. So now if you believe that this zircon is millions of years old and zircons move in and out of systems, I can give you plenty of information on that. Then how can you rule out that it was ever around phosphorus that didn't bring in additional lead? And if you can bring
Do you think
lead
there's
in or take lead
ways that we
out,
could? Do you think that there's ways we could test if it's around phosphorus?
not if the zircon, you would have to say that zircon has remained in this location and there was never any phosphorus around ever. And if it's a billion years old, how are you going to make that extrapolation? Especially since zircon crystals can move in and out of systems. I mean, they know that they can inherit old ones and new ones.
So you're saying phosphorus can leach lead into the zircon crystals, right?
I might
Is
be
that what I'm
getting the
hearing?
name of the element wrong, but it's yeah. I can look it up if you'd like, but it's one of those elements.
Okay. Do you think like the amount, even if that is true, do you think the amount of lead that's being leached into the zircon crystals would give the difference between 6,000 and 4.5 billion?
It messes up the date. It makes it unreliable, so it wouldn't matter what date it gives you. If the date's not reliable, who cares what date it gives you?
Because the difference between it would be so severe on the half-life curve of uranium
Yeah, but
238 or whatever you're dating.
they only try to date the concurrent ones, right? So you got the two clocks, right? So uranium 204 decays into lead 206, and so forth and so on. So you got the two uranium markers. The only ones that they try to test are the ones that are concurrent or congruent. Congruent's the word. So they have first of all, there is no congruent level. And some of these studies, you got to look at what the congruent number is. It could be up to 10%. So they can just say that there's a 10% difference here, but they just call it congruent because that's their standard. So they only test the ones that are supposed to be congruent. Okay, so that's just like having four dice. And you only test the ones that match. So if you have four dice, what are the chances?
I don't guess I understand what you're saying. You might have to rephrase it.
Okay. Do you know how they, like what zircon crystals they test?
No, just yeah. Tell me. Go ahead.
Yeah, so they try to weed out all the problems that they get with zircon crystals to make sure that leaching can't be a problem. They're very smart. I'm not saying that these guys don't have a good method. They try to weed out all the, like a zircon crystal that has cracks in it. That can allow leaching in and out, so clearly they don't want to date that one because it's got a problem. And then you got uranium inside the zircon crystal that decays into lead. And then you got two different types of uranium that decays into two different types of lead. So when you, like lead 206, lead 208. So you want to make sure that the amount of uranium and decay into lead, that those two are congruent, meaning that they match. If you have one way up here and one way down here, then they don't want to test that crystal because there could be a problem with it. There could be leaching. If the zircon crystal is actually if it's truly in a closed system and it started off with the uranium and it had no lead in it, then the uranium decayed into lead. The two lead should match. It's called being congruent. You with me so far?
Sort of. I don't understand what you're saying about the uranium and the lead have to be the same amounts in order for them to date it.
They don't test it if it's not congruent. You might get some labs that do it as an outlier, but you're not
What
going
I
to
hear
test
is
it if
like
it's not
they don't test it.
congruent.
What I hear is you're saying they don't test, they don't radiometrically date things if it's not a 1-to-1 parent to daughter isotope ratio.
Now that wouldn't be my argument. They might test a lot of them, but if the two dates aren't congruent, then they wouldn't. But why would you waste your time on that? Because
You're saying the two dates. Okay, I thought it was parent isotope and daughter isotope.
Yeah, parent isotope and dot. But the uranium, you got two different types of uranium that decay into lead, right? Lead 206, lead 208. If the two leads don't match, then you wouldn't date that because you've automatically assumed that there's been leaching. So you want to get rid of those crystals, right?
Okay. I mean, there's I don't know enough about this, but I know there's argon dating, potassium. They use potassium as well. Potassium argon dating. So I don't know.
Yeah,
I don't see any reason to distrust it.
Well, it has all the same fundamental problems in it. Let me give an example.
Right, you would argue like the closed system perspective.
Yeah, no,
probably.
it's in an open system. But yeah, let me give an example. You and I walk into a room, right? We're at this party, we're chilling. We walk into a room, and in the corner of the room, there is a candle lit. It's burning. And I ask you, I say, hey, brother, when was that candle lit? You say, I don't know. We have no idea. So let's go do some empirical science on this candle to determine when it was lit. So you and I, we pull a tape measure out, we measure the candle. The candle is 10 inches tall. We wait 1 hour. The candle is now 9 inches tall. We wait 2 hours. The candle is now 8 inches tall. We wait 3 hours so we can plot our graph. So we got 3 points. We wait 3 hours. It's now 7 inches tall. We have now successfully determined that the burn rate, aka the decay rate, is constant. It's not going to change. When was it lit? You don't know. And you're never going to be able to answer that question unless you make an assumption of how tall the candle was. I can get whatever.
That's not accurate though for. That's not accurate for radiometric dating.
It is.
Because no, it's not. But
okay,
okay.
I can give you. I can show you. Yes, it is. It's exact. You have to know, like carbon-14. You have to know how much was in the atmosphere when the animal unalived.
Carbon-14 aside, like if we're talking about radioactive decay of different elements,
that count. Carbon-14 counts.
If you assume the half-life is constant, which is the one thing you're willing to grant, if half-life decay is constant, then you don't need to know the initial parent amount.
What?
To determine.
What?
It's called isochron dating.
How does that work?
It's called isochron dating. So the half-life decay curve is a logarithmic curve. Okay, so like you said, it starts up here, slope is nearly undefined, and it goes down towards zero, but it never actually approaches zero. It hits the asymptote of zero. If you take two different samples of the rock that you're trying to test, and you'll get a range of dates, at least two, you can do more. If you do this and you plot it on a slope, this slope of the data points that you plot will give you the age of the rock, the absolute age of the rock, assuming that half-life decay is constant. It's called isochron dating.
Yeah, I've looked at isochron dating, and
it's just math.
yeah, but you already know that they have assumptions that go into isochron dating too, right?
That's what I'm saying. If you assume that the half-life decay is constant, which I do, I don't see any reason to doubt that. Then that's the case.
Yeah.
Then you can determine the absolute date of a rock without having to know the initial parent isotope.
I don't see that. I don't see that at all.
Okay. It's a math problem.
They're doing it off of the graph, but then when I look it up, they are baked in assumptions into it. And one, you do have to assume parent material.
No, you don't. That's the whole point of isochronic dating. Because the slope, the distance between the 2 points and the slope between the 2 points will tell you at which part of the decay rate you're in.
How does that work if you've got
if the curve is like this, right? Like we're imagining the same half-life decay curve. It's a logarithmic curve. If the slope is closer to zero, then we know the data looks more like this.
Okay.
If we know the half-life, the slope would be a precise number. If you know the half-life, you can determine at which point you are on this graph of the decay.
Okay, so uranium decays into lead. You've got 50% lead and 50% uranium inside the zircon crystal. To make the math simple, let's say that the half-life is 1 billion years. We know the crystal's 1 billion years old because in our make-believe scenario, the uranium decayed into lead, half of it's still there, so it's 1 billion years old. How do you, not knowing the parent material, get you to the age?
You need multiple measurements. That's the first thing. You can't just do it on one measurement because you need to make a slope. So you would take a rock and you would measure it at different points in the rock, and then you would plot this on a graph.
What do you?
And that would give you this.
Measuring what?
You're measuring the number, the ratio of the parent to daughter.
So you have to assume the parent.
No, you're not understanding. You assume you don't have to assume the initial amount of the daughter isotope or the parent isotope. You don't have to assume anything.
You have to assume that the samples must be the same age as the closure event. I mean, that's what I'm looking at right here.
The same age as what?
The same age as the closure event, meaning that the rock, I guess you're dating around it, because it's not making.
Yeah, like you would assume. So if you have a rock, you would assume that it would be formed in a similar time period, right?
So now you have to assume the zircon didn't move when we know that zircons can move in and out of systems. Like
this sedimentary rock, right? Like I would take a sample from right here, and I would take a sample from right here, and a sample from right here, and right here, right here, right here, here. And then I would measure the parent and the daughter isotopes, and let's say it's 2 to 1. Like there's two parents for every daughter.
Yeah, but here's the biggest fundamental flaw.
You plot that on a graph, and the slope will tell you the absolute age.
Okay, but still, your biggest flaw is you have to assume that it's in a closed system.
Right. And that's why I was thinking about that. Exactly when we started talking about it, I was like, I don't know how I want to push back on the closed system thing. I don't know enough about it to argue whether or not it is a closed system or not. But I have no reason to doubt that it isn't a closed system. So,
Well, I can give you plenty of reasons to doubt that it's a closed system because it doesn't exist on the planet. That's why. You can't give me one example of a closed system on the planet. Give me one example.
Well, the
of
universe is a
radiometric
closed
dating
system, I
that's-
guess. Yeah.
Give me one example of radiometric dating being in a closed system anywhere. And the moment
I told you,
I'm gonna
I
say
don't know enough
carbon 14 is
about.
found in dinosaurs, and then therefore I win.
Okay. All right.
All right. Well,
So yeah,
look, yeah.
Yeah, the half-life decay thing. It is an error to say that you need to know the initial parent amount of that isotope. It is because if you assume
factors, okay, fair. If you
if
know
you
all
assume the
other
half-life,
factors, but that you don't know it, you clearly have to assume it. So if
right,
you
that's
know
what your argument would be. Yeah.
Yeah, so that's what your argument would be. If you know all the factors, then yes. If you know, like, you got A, B, C, and D. If you know B and C and D, then by default you can know what A is. I will grant you that. So you might not need to know it in that case. Still got the biggest problem, man. You have to assume this is in a closed system, man. And we just know that
right.
doesn't exist on the planet.
And then I guess my issue with that is like I said earlier, the difference between the difference between a 4 billion year rock and a 6,000-year-old rock in terms of half-life decay is like exponentially wrong. You know, in science they give like degrees of error, like plus or minus this many percentage, right? Like that would be not even in the same ballpark of measurement.
Are you familiar with the other fields of science that they have to come up with in an effort to prop up radiometric dating because it doesn't work? Hall-set plateau, wiggle matching, the marine reservoir effect. You all have to come up with these new fields of science because radiometric dating doesn't work. Do you know that if you eat shellfish, that your radiometric dates will be off by centuries?
I disagree with the premise of the question.
Well, I'm sorry. You can look it up. It's actually called the
objection. Leading the witness.
Okay, the Repton Viking burial site, right? Repton Viking burial site. We've seen this, so we could date the site by the coins that the Vikings had on them. So, in other words, if I unalived with a 2026 coin in my pocket, then clearly I didn't unalive in 1986, right? Because there's no way I could get a future coin in my pocket. So that gives
that's not true. You're making assumptions there.
So what?
You're making assumptions, right?
No.
You need to justify your assumptions. You're assuming that it's a closed system. Somebody could have came in and placed a coin there, right?
Yeah, somebody come in and dug them up and then left no evidence behind and put a coin in there.
Hey, now you understand my frustration. Okay, all right. Continue.
Well, mine's logical. I think yours is a rescue technique. There's a difference.
Likewise.
So,
okay.
Okay, just saying it doesn't help you out none, but okay, I got you. Let's get back on track. So the Repton Viking burial site, we can pretty much date the site because of the coins that they have on them, bar some ninja coming into the middle of the night and sticking coins in their pockets and then reburying them.
Logically possible, not logically impossible, not a closed system. Go ahead.
Sure. And then, the problem that we found is that the radiometric datings were off by centuries. And then the determination actually, the reason why they found this out is called the marine reservoir effect. The Vikings ate shellfish. And because the Vikings ate shellfish, then the radiometric dates were off by centuries. So now, if you're going to carbon-14 date something, you need to know their diet too. You have to imagine.
I'm glad I didn't talk about carbon-14 dating then. Yeah,
well, that's radiometric. It's part of radiometric. I'm just showing you. I'm just giving this as an example, but it is radiometric.
Okay, all right. What is that thing? Gamer Otter. Good stuff. Yeah, people in the chat are like, "What the heck is going on?" Like with the debate. They probably want me to push real hard. They probably want you to push real hard, and so we can go like this.
Oh man, we ain't gonna do that.
I don't know. Take a different approach.
I will say this, brother. You faced how long you been doing this?
A year, maybe.
You've been doing this?
I've been
debates right here for a year.
Yeah, less than a year. I don't even know if I'd call it debates, but I've been learning about this stuff and studying it probably the last 2 years. So.
Okay. Well, okay. Never mind then.
You're gonna say you're really good, and then you're like, oh shoot, you should be better for two years.
Well, I was I wasn't going to insult you like that. I was going to say I thought you were new at this.
No,
I haven't run across your live, and I
no,
was going to
I would still
say
call myself new, but yeah,
you had VOR in here yesterday, and you have me in here today, and we are. I think he's bigger than I am clearly, but I think we're probably two of the biggest creation debaters that I know on TikTok. There may be
really,
yeah, there may be bigger than me or him. I'm just unaware of them, so I don't want to pretend like I have all this clout. But I know of him
yeah.
definitely, and then myself.
I never heard of a VOR until he came in my chat, and somebody said that's VOR, and so I checked his followers, and he had like 250,000 followers, and
Yeah,
yeah, so I
Kent
never heard of him until
Hovind.
yesterday, which makes sense.
Kent. Somebody said Kent. Yeah, they're 100% right, but Kent doesn't do what me and VOR does. He does the more structured debate. He teaches on TikTok, but he doesn't do like what we do as far as daily debates, basically.
Yeah, it's good entertainment for me, and probably for you too. It's fun.
I enjoy the conversations. That way, both sides can hear it. So I appreciate it, man.
Yeah, likewise. Have a good night.
All right, man. Listen, before I go, this is the reason why I do this, right? I do it for two reasons. One, I want to
Oh,
strengthen the
okay.
faith of the Christian. Yeah, help me out. Let me tell you why.
No,
One,
let me. No, never mind. You don't know me well. Never mind. Go
it's
ahead.
your lie. It's your lie, brother. You're not gonna hurt my feelings. I deal with the ACS all day. But here's my thing.
I was gonna
Number
preach to
one,
myself, but you go ahead.
go ahead. I do this because I want to strengthen the faith of the Christians, right? Show them that what the Bible says is literally true and scientifically accurate. And then secondly, I do it so I can try to save the lost and share the Christ with them. So I don't plan on doing it on a public platform to make you uncomfortable. But if you'd ever like to hear more about Jesus, man, give me a shout. I'd love to share him with you.
Thank you. I appreciate it.
All right, man. God bless.
Likewise. See you later.
Uh huh.
See you later.
Uh huh.